Hello, this is Patrick from Royas, and today I'll be teaching you how to make Flappy Bird from scratch with C# and Godot. Let's dive right in. So first thing we are going to want to do is we're going to want to change the viewport size to be more phone shaped. So we're going to go to Project, Project Settings, Window, and I'm going to change this viewport width to 480 by 800. And then I'm going to scroll down to this stretch mode and set it to viewport, and the aspect I'm going to leave on keep. So that should, okay, yeah, it already set that. So now I'm going to set the current scene to this one. And that's more phone shaped. All right, so now we're going to want to make the player. So I'm going to go Control A, go rigid body, 2D. Then I am going to go, okay, I'm going to go collision, shape 2D. And then I'm going to also add a sprite 2D. And then the collision shape I am going to set to be a circle. Okay, so now that we've got this, I'm going to go and get our character sprite that is in the tiles, characters, and then I'm going to just drag this sprite onto here. Okay, perfect. Now I'm going to resize the collider to be about the same size as the character, and the character looks kind of ugly, so I'm going to go to visibility, texture, filter, and then nearest. And that's going to make the pixels look a lot crisper on this sprite. Okay, now we're going to need to make a script. Oh, wait. And so I'm going to make a new folder, scripts. Then I'm going to go create new, actually, I'm just going to create this on here, new script, rigid body, and I'm going to place this in the scripts folder, open, and I'm going to change this to player.cs. Okay, so now in this, we are going to make some variables and we're going to export them. So we're going to export a float, and we'll call this speed, and we'll set that speed to be 200. And then we'll export another float. So export float, and then we'll call that jump power. And then we'll set that to 350. Then we will export another thing, and this will be once again another float, and we'll call this reset timer. So this, when the player crashes, this will be how long it takes before the game reloads. All right, we'll need to make a couple private variables now. So we'll go private vector2, and we'll name this variable movement this frame. And we'll set that equal to a new vector2. And then we will do another private vector2 jump impulse. And we'll set that also to be equal to a new vector2. Now we'll go over to ready here, and we'll go movement this frame dot x is equal to speed. And then we will go jump impulse dot y is equal to negative jump power. Since going up on the screen moves down on the y. Okay, so now we're going to go over to a type public override void. Whoops. I'll just do underscore physics process. Yeah, that was harder to say than it should have been. Okay, so now I'm going to do movement this frame dot y is equal to linear velocity dot y. And then I'll say the linear velocity is equal to movement this frame. So what this does is this makes sure that when we jump, we don't override the upwards force that we're applying to the character. Now to jump, what we're going to do is, so you jump every time you tap the screen. So we'll go underscore public override underscore input. Perfect. And then we will say if the event is input event screen touch, and then we'll call this touch and touch dot pressed. So that's if they pressed it, then we'll make the character jump. So to do that, we will go movement this frame dot y is equal to 0f. So we'll cancel out their current y velocity on the frame. Then we'll go linear velocity is equal to movement this frame. So we're applying that canceled out velocity. And then we'll go jump impulse and then we'll go apply impulse jump impulse. So what's this is doing is just if the character's falling down quite a bit and you apply an upwards force, it'll be kind of canceled out by the downwards force that the character is feeling. So we're just getting rid of the downward force and then applying it. So that way it'll feel consistent each time the player taps the screen. And just for testing, we'll do an else if event is input event key, just so we can use keyboard controls, event key, and event key dot pressed and event key dot key code is equal to key dot space. And I'm just going to make this a function private void jump. And I'm going to put this code in it so that it'll be the same for either of them. And if we make a change in one, we'll make a change in both. Jump. And jump. Perfect. All right, so now let's see if our character starts jumping. Yay, he's jumping. He is a little small though, so I'm gonna actually grow him a little bit. I am going to make him twice as big. Perfect. Then the collision shape will be that size. Let's check that again. Much better. And I'm gonna flip them around so they're not flying backwards. I'm gonna flip H. There we go. Now the character is going to be facing the right direction, and every time we tap the screen or press spacebar, they jump. Perfect. So now what we're going to want to do is we're going to have the camera follow the character, and I'm actually just going to drag the character to approximately the middle of the screen. So what we're going to want to do is have the camera follow the character. So what I'm going to do is I'm going to make some ground that follows the character, and that's going to have the camera attached. So what I'm going to do is a character body 2D. There we go. And then I'm going to give it a collision shape. And the collision shape I'm going to set to a new rectangle. And then And I think that's pretty much it, actually. Okay, I'm going to drag this collision shape down. So what this is going to do is it's just going to follow the player everywhere they go. I'm going to put that approximately there. That seems good. We're going to make a script, and we're going to put it, oh, okay, it's there already. Perfect. And we will call this ground. I'm making this a character body 2D because I don't want physics applied to this. I'm also going to switch this to node because we don't want all the movement stuff put into it. Okay, and so for the ground, what we're going to want to do is make an export variable, and we'll call this player. So we are just going to get reference to the player. And then we're going to have a float y position. And the y position we're going to set to the position that it starts at. So position dot y. This way the barrier never changes where it's at on the y, it only changes where it's at on the x. So we'll say vector2 dot position, not dot, sorry, pause, is equal to player dot position. There we go. And then we'll go position or pause dot y is equal to y pause. Perfect. And then we'll say the position of this is equal to pause. Now we will move and slide. And after we move and slide, what we're going to want to do is get the collisions. So if the player rams into this, we will tell them that they've hit it. So we'll go for and get slide collisions, collision count. That'll just tell us what the contacts are. So we'll get a kinematic collision 2D collision. We'll set that equal to get slide collision I. And then we'll say, okay, if the collision dot get collider dot get class is equal to, actually, I am going to change this. Collision dot get collider dot as method, and then I'm going to have the method, let's call it stop player. So if it has the method, what we can do is then copy this dot call stop player. So now we'll go back to the player. We'll make a public void stop player function for it to call. And what this will do is we'll make a private variable up here, and we'll make it a bool, and we'll have it called has crashed isn't equal to false. So now we'll set has crashed equal to true. So now if we have crashed, we'll return. And we'll do that here as well. Perfect. So now when the player collides with this, they'll crash and that'll be perfect. Oh, right. And I wanted to add a character to this. So, or camera. Okay. And I'll actually just move the character to where that is so that they're overlapping. Okay, so now let's drag this character in. Oh wait, we need to run it so that it gets the stuff on the side here. Perfect. And we'll just assign the player. And now it doesn't look like we're moving, but like the character's staying on screen and they were moving before. So we need something on the background to show movement. So to do that, what we're going to need to do is go over here and do a parallax layer, or not the parallax background. There we go. And then the layer goes in the background. Okay, now we just click on this and we will create a sprite 2D. So sprite 2D. And then this will be our sky. So we'll take the beach sky into this. Nice. And we'll set this to be mirroring 920 by 1080, 920. Don't need the 1080 because we're not going up on the Y. Now we're gonna duplicate this and do another sprite. We'll just drag this sprite over, and then we will once again change this, but we'll change the scale this time and we'll put that at 0.1. That's going to make it scale very slowly, so we'll duplicate this once again. And then we will change the sprite to be, let's have some mountains. And then we will change this to be, oh, we don't want to scale on the Y. Whoops. We'll put that as 1. And we'll put this back to 1. We'll drag these down to be there. And we'll do the same with the clouds. But we'll put the clouds up there. We'll duplicate it once more. We'll change the sprite to be these other clouds. So we'll have clouds in the back and clouds in the front. We'll put these clouds up, like, let's say about here. And we will set these scales to 0.25. So these will, the closer clouds will kind of fly faster than the clouds in the background. Okay, we'll duplicate this once again. And here's one thing I really, really like about Godot's parallax effect is you can actually put tile maps in here. So tile map, then I am going to go to tile set, new tile set. Let's drag in these tiles. Yes. Okay. So we want tiles that are 18 by 18. They'll have a separation of 1 pixel by 1 pixel. So that's our tiles. Now I am going to go to the tile map. I'm going to select this tile. Well, first I'm going to go over here, set the tile size to 18 by 18. Oh yeah, and I forgot to change this back to this. So now I'm going to go here, draw these tiles. Gonna get rid of these until there. Then put these here. Gonna switch to this box select. And there we go. So now we need to just set up this mirroring, which is way too big. So I'm going to try around 486. That looks about right. Seems pretty seamless to me. So now let's see how this parallax effect works and helps show motion. Much better, although I think the ground could be moved up a bit more. So I'm going to do that right now. Ground up. Then to match that, I am going to take the character body and move that up to match where the ground height is. Then I'm going to take the camera in the character body and move that back down to be in the correct spot. Perfect. So now we're going to be able to go like that, and it kind of derps out. Okay, to fix that, we'll just go back to our player. We'll go in this stop player. We will change the linear velocity to equal vector2.0. And then we'll set the gravity scale equal to 0 as well. And we will turn the locking rotation off so that they can kind of like roll and whatever to give it like a bit more of a effect. False. So let's see if that fixes it. And there we go. They just kind of fall and stop when they hit the ground. Perfect. Okay, so now what we're going to do is we're going to have to make the pillars that the player can fly between to score points and glide in with, or fly into and die. Okay, to do that, we're going to go and make a new scene. It's going to be a 2D scene, and we're going to add a couple of static bodies. So we're going to go static body 2D. And we're going to give this static body a collision shape. And then we're going to make the collision shape a rectangle. And then we are going to give it a couple 9 patch rects. Duplicate that. And so what these 9 patch rects are going to be the textures. So we're going to go to tiles. So this first one, we're going to give this. We're going to also change the texture to be nearest. We're going to do the same with this one. Texture, filter, nearest. Going to drag this one down, and we'll set up this 9 patch rect. So we'll go edit region, zoom in, and we'll drag these bars around. Oh, no, I want the bar, not the, there we go. And then we'll leave that bottom one there. So what that's going to do is make this expandable. And we'll be able to stretch it out and whatnot. Go to edit this region as well. We'll drag these bars once again. And there we go. So now what we can do is drag this out, and that's going to look weird. Go to axis stretch, vertical, and then we will say tile or tile fit, and it makes it kind of loop. So at the top one, we can also do that as well. Tile fit. Now it looks proper. So we'll take this collision shape and just match it to that. And we'll go probably quite a bit down. Actually, since this is the bottom one, we're gonna wanna do that. We'll take the collision shape way down like that. Then we'll duplicate this and we'll drag it up. We'll give it a new collision shape. So new rectangle shape. Then we will rotate this on the transform by 180 degrees. And so that way it's upside down. Now we'll just do the collision shape. This one we will probably just match to the collision shape, so we'll just drag that up, and then we'll drag this 9 patch rect and drag that way up too. Perfect. Now we will create an area 2D. This will detect when the player passes through so that it'll know when to award them points. And then we'll give this area 2D a shape as well. And that will also be a rectangle. We'll put that like this. We're offsetting it a little bit so that when the player passes, like, so if the player just kind of hits the edge here, they don't hit this, and then they don't get a point if they just flip the edge and die. Let's figure out how big this should be. I'm going to just check this here, and I think probably about 170 would probably be a better height for the player to go through. Then we will just drag these static bodies to match that. There we go. That should be a nice big gap for the players to go through. So the problem is like when we place this, we don't know what the height or at what position we're going to be placing it at. So this one isn't going to go all the way to the ground all of the time. So we'll have to write a script that'll stretch out this bottom 9 patch rect to the ground whenever it's placed. So let's go ahead and create a script. I'll place it on the barrier. So new script, we'll call this barrier. We'll put that in the scripts folder and we'll click create. Okay, we'll export a couple of variables here. So we'll go export 9 patch rect, bottom barrier, sprite, and then we will export float ground height. Okay, and then we'll also have a bool as set sprite, and we'll set that equal to false. So we can get rid of this ready function, and in process we can go if as set sprite turn. Then we'll go if bottom barrier sprite does not equal null, then we will set has set sprite is equal to true. We'll say vector2 new size is equal to bottom barrier sprite dot size, and then new size dot y is equal to ground height minus bottom barrier sprite dot global position dot y. We'll set the bottom barrier sprite dot size equal to size. All right, that should be good for that. Now we'll just need to spawn these every certain distance so that, you know, the player can run into them. To do that, we'll go back to the level scene. Actually, first we'll have to save this scene, and we'll call this barrier. Then we'll go to the level scene. We'll minimize this. We'll go Control A and we'll do a node. Drag this to the top. We'll call this Game Manager. And we'll make a new Game Manager script. Put that in the scripts folder. Okay, now for the Game Manager, we will go using system.io because this will save and load all the scores as well. So this will handle the score keeping and the spawning of the barriers and the reloading as well. So we'll go public static game manager instance. Then we'll go export packed scene barrier scene. Then we'll export the gap between barriers. So we'll go export float gap between barriers, and we'll set that to about 550 F. Then we will say spawn height range, export vector2 spawn height range. So this will be the range that we can spawn the obstacles within height wise. And we can set that to about, let's try new vector2 150 and 550. Oh, okay. Oh, whoops. Forgot the equal sign. And then we will also need the player to know where they are. So export player. Okay, now on ready, okay, public override underscore ready. We'll set the instance equal to this. So that's just setting the singleton. And that's all we'll be doing for now until we want to save and load data. So now we'll go public override underscore process. So we'll say, oh, we'll need to make a couple private variables as well. I forgot about those. Okay, so the first private variable is going to be private float last player x is equal to 0f. Then we'll have a private float players x tally. We'll set that also equal to 0f. So that'll just be like tallying how far the player has traveled. And then we'll go private int score, just, for future reference, we'll set that to 0. We'll go private int high score. We'll set that equal to 0 as well. Okay. So now on every frame, we can go players x tally plus equals player dot position dot x minus the last player's x, and we'll set last player's x equal to player dot position dot x. This way, every time the player moves a little bit, it's adding the distance that they've traveled to the tally. So now if the player's x tally is greater than or equal to the gap between barriers, we will spawn a new barrier. So we'll first set the player's x tally back to 0, so it's not constantly be calling this. And then we will spawn the barrier. So node 2D barrier. is equal to barrier scene dot instantiate node 2D. We'll add a child to this. Add child barrier. Okay, and then we'll set the Y position of the barrier and the X position. So float Y pause is equal to float GD dot rand range. Oops. Spawn height range dot X, which will be the lower bound, and spawn height range dot Y will be the upper bound. And then barrier dot position is equal to new vector2 player dot position dot X plus the gap between barriers and the Y position. All right, let's go back to Godot and test this out. So I'm just going to run it first to get the property showing up. Okay, so first things first is we're going to assign the player. I'm going to rename the player. And then we will also have to assign I'm just going to minimize these. We don't need those anymore. The barrier scene. Okay, so we're going around and okay, so we placed the barrier too high for 1, and for 2, it didn't stretch the bottom out, and I'm pretty sure I know why that is in the barrier scene, we never assigned the bottom barrier 9 patch. Or we also didn't set the ground height either, so we should probably do that too. So the collision shape, actually the character body transform is 779. Collision shape, how tall is that? 20 and a half, so 779, so 789. I think is the correct number here. And let's make these not spawn as high either. So let's put this at a maximum of 300. That might be a better range. It flying along. That didn't work either. And you'll see that we're kind of jittery and getting stuck on these barriers every once in a while. And we're also not dying when we hit the barriers. We're also spinning. So I'm going to go onto the player first and go to I forget what it's called. Constant forces, no, solver, activation. Oh, yes. Lock rotation. We're going to lock the rotation on the deactivation tab. And then this character body, we'll move that to a different layer that doesn't collide with posts. So we'll go collision. We'll move this to layer 2. And we will allow this to collide with layer 3. And we'll move the player collision. We'll move them to layer 3, and we'll have them collide with layer 1 and 2. So that should be smoother first off. Okay, perfect. It's a lot smoother. I just noticed the ground looks really weird, and I'm pretty sure it's because, yeah, I didn't set this to 1. Much better. All right. Okay, so I figured out why the bottom barrier wasn't going to the ground visually was because for one, I had the ground height wrong. I added 10 instead of removing 10. I also dragged in the 9 patch rect from the top and not the bottom one. And so if I play it now, it should work. Yeah. Okay, but now the player's not dying. So we need to go in and fix that. So we'll go to the player script and we'll make a function that's a public void on body entered. And then we'll have a node body. So when this happens, what we will do is we'll say if has crashed, we'll return because we don't want to duplicate that. And then we'll just set has crashed is equal to true. Now we'll have to go and wire that up. So we'll go back, we'll go to our player. First thing we got to do is go to the solver. We'll set the max contacts to, let's just say 2. And then we will set contact monitoring to on. So now it can actually detect when it's collided with things. We will now go to body entered and we'll connect that to player. Why is that? Player, pick, methods. Oh, right. Got to run it first. So connect, player, pick, on body entered, connect. So now that's all wired up. Let's see if that works. Perfect. Player dies. Well, now that we've got the player dying, we'll need to reset the game when they die. So what we're going to do here in process is if not has crashed, we'll return. And we'll do a private float up here. Time since death. We'll set that to 0f. And then we'll go time since death plus equals float delta. Then we'll say if time since death is greater than reset timer, then we will go into the game manager and make a function we will call reload. So public void load. Then we'll say, we'll go to export node current scene. We'll go current scene dot get tree dot reload current scene. So let's see if this works. Oh, yeah. Oh, it's node 2D as well. Sign node 2D. So I'll just drop here. Oh. Game manager dot instance dot reload. Whoops. So now you'll see crash and reload. Perfect. Crash, reload. Wonderful. Okay, now what we got to do is we got to start keeping scores, because what's a game without scores? So in the game manager, we'll go and add a function called public void add point. Then we will go up here and private, or we have already got the score, right? I did that preemptively. Score plus plus. Now we can also export a couple of text labels. So export rich text label current score, and then we'll export another one, rich text label, and we'll call this high score label. Well, I misspelled that. And in here, whoops, I will go current score label dot text is equal to score dot toString. All right, so now let's go and make the canvas. Control A, canvas. Layer. All right, now we'll make the rich text label. So we'll do rich text label. We'll call this one current score label. Then we'll duplicate this. This will be current score. Current score label, leave there. Current score, we'll over. Current score label, the text will be current score. I will drag this out, and I'll add a semicolon or colon here, and then current score, move here, and I'll just set the text color to black. Display text, oh, visibility, modulate. Yes, there we go. And then this I will just set to 0, and also go to visibility, modulate, black. So now we'll duplicate these, drag them over. We'll make this the high score and high score. We'll change the high score one to be obviously high score, and we'll drag the high score label closer there. Now we'll run it so that we can get these things in the game manager. We'll drag in the current score and then the high score. Now we'll have to get these, notify the game manager when we've added a point, and we'll do that on this area. So we'll go script, new script, C#, or point score. Point score, sure. And we'll put that in the scripts folder. We'll get rid of these. And then we'll do public void on body exit. And then that should get us, oh wait, I should check and see if this takes a node or a node 2D on the on body exited, on area exited, area 2D. Oh yeah, on body exited, node 2D. Okay, so it takes a node 2D. Node to body. So then we'll say if body dot get class does not equal to rigid body 2D, we'll return. Then we'll say player is equal to player body. So then we'll say if player doesn't equal null, so if it can actually convert it, and not player dot has, oh, I should make the has crash public. I'm gonna move this up there. There we go. And then I will change this to get, which will remain public, and then private set has crashed. Then we will add the point. So we'll go game manager dot instance dot add point. Okay, so let's run this. Oh wait, I need to do this on body exited and pick. All right, pick here. Oh, I put the script on the collision shape. Whoops. I am going to move that. So I'm going to clear this, edit this script to be area 2D, then go to scripts, point scorer, drag that in. There we go. Now run it. Now I should be able to connect. Pick. There we go. Connect. Okay, save that. Oh, yeah. I need to make the area collide with, I think it's 3. Whoops. There we go. Okay, now we've got scorekeeping. You can make that however pretty as you want. I'm just doing something very, very basic right now. Now we want to save the high score and load that back when the player reaches a new high score and whenever they load up the game. So we'll do that in Game Manager. We'll make a private string path, private string path, and we'll just have that there. So we'll have string data. Okay, and then we'll set path equal to path dot join project settings dot globalize path. Then we'll give it the path user :// and then we will make a high score dot, oh wait, I should put this in text. High score dot text. Now, if not file.exists path, we will return since there's no high score. Now we'll try get data is equal to file.read all text path. Then we'll int dot try parse. So hopefully this will be in the right format. We'll do data, then out high score. And then high score label, we'll set dot text is equal to high score dot toString. That should load it back. Then we'll catch this. If it fails, system.exception. And I'm not really going to do anything with the exception right now. Okay, so when we reload now, we can check to see, actually, I'll do this above. If score is greater than high score, then we'll save it. So we'll go file.write all text. We'll give it the path, then score.toString. All right, now let's run it again. Okay, now I'm going to crash. So our high score should be 1. Oh, it's getting errors. What are these errors? Okay, so I think I know what I did wrong here. I misspelt this. User. Ah. I've been misspelling like mad today. So user, that should now work. And we've got a high score of 1 now. All right, so one last thing to bring this game to life is sound effects, because it's kind of dead right now. So I'm just going to go and show you how to do that. So we'll go back to level. We'll go back to the player. And we will create a couple of audio stream players. 2D. Actually, no, we don't need 2D. So we'll just go audio stream player. And then this will be jump sounds. And then we'll make another one. We'll just call this other sounds. Perfect. So now we'll go into the player script. We'll export the audio clips. So we'll go export audio stream WAV or WAV, jump SFX. We'll then export. I'll just copy this actually. Score SFX and die SFX. Now we'll have to get the audio stream players, so we'll go private audio stream player jump player, and then I'll copy this, paste that, and we'll call this other player. Okay. So now I'll get the jump player and set that equal to get node audio stream player. and we'll call this, we'll copy this so I don't mistype it. And then we'll duplicate this. Other player, go here, copy this. And there we go. We'll have our players. All right, so first we'll go to jump and we'll go jump player dot stream is equal to jump SFX and jump player dot play. So now every time the player jumps, it'll make the sound. We will now do the same for the on body entered. So when the player crashes with something, we will go other player dot stream is equal to die SFX other player dot play. We'll also do a function for when they score the points. So public void point scored SFX, and then I am going to do other player dot stream is equal to score SFX, and other player dot play. Okay, so we'll run this, and then we should have these open now or appearing, and we'll go sounds. So fail is going to be die, jump is going to be jump, points gained is going to be points gained. I just found these sound effects online, so they're nothing special. It didn't make a sound there, but making a sound when they jump makes a sound when they run into a wall. Oh, right, and we're not calling the function from the game manager, and they score a point. Player dot point score SFX. There we go. And I think when we call stop player, we should also do the die sound effects. Perfect. Okay, so it spams that. To fix the spamming, we will just do if as crashed turn. There we go. Perfect. All right, everything works. All right, thank you very much for watching. And also, this will work on mobile. You won't have to press spacebar or anything like that. This should run on your phone as well. I have tested it. It works fine on mine. So thanks for watching. If you liked the video, please like and subscribe. And if there's anything else you'd like to see me build, please let me know. Thanks. Bye.